All right, so for tonight's homework, there's going to be some more complicated things building on the things we've done the last couple days, but this is a whole new concept, so I'm going to start with the whole new concept first. It's called, what you need to be able to do is you need to be able to solve systems of linear equations. And the weird word here that we're not used to is the word systems. So what is a system? And a system, I mean, this isn't that complicated. All that a system is multiple equations. Multiple equations. And so when we're saying solve a system of equations, we're trying to see where multiple equations are true at the same time. So, for example, I might give you a question that says something like this. It might say, okay, solve this system. And I'll give you two equations. I'd say something like y equals x plus 3 and y equals negative 1/2 x plus 3. Okay. I might give you an equation like this, where I'm saying, okay, let's solve this system of equations. And so the way I'm going to first start by asking you to do this is I'm going to ask you to do it by graphing. By graphing. Okay. And so to be able to do this, it's not that terrible. All we have to do is graph both equations. Okay, graph both equations. So here's this. I'll go ahead and do my little hash marks. And I'll do each equation in a different color. This first one I will do in red. And this second one, let's say purple. Okay. So I'll start with my first one. My first equation is y equals x plus 3. I can tell that my intercept is going to be 3 and my slope is going to be 1. Knowing that, I can now graph. I can go up 1, 2, 3. My slope is 1, so I go up 1 over 1. Just like that. I have 2 points. 2 points make a line. I will draw them. Put arrowheads on the end to show that they go on forever, and call it good. Next, I will do my second equation. My second equation is y equals negative 1/2 x plus 3. From this, I can see that my b is 3, and my m is negative 1/2. So I will go ahead and plot my point. Here is b. I go down 1 over 2, like that. I have 2 points. I draw a line connecting them, put arrowheads on the end to show that they go on forever, and now I have graphed them both. Excellent. Okay, so I have successfully graphed both of my lines. Now I need to figure out where it is that they're both true at the same time. So when I'm looking for the solution is where they cross. It's where they cross. And I can see they cross right there. They cross right there. That's their intersection. And so I look at that intersection, and so I have to see what point that is. And I know that the x-coordinate is 0, right? That's 0. And the y-coordinate is 1, 2, 3. 3. So I would say that the solution to this system is the point 0, 3. Okay? Solution. So whenever we have a system of equations, the solution is where they cross. The solution is where both lines cross each other. And you're going to write your solution as a point. In this case, the point was 0, 3, because that's where both of the lines crossed. Any clarifying questions? Yeah? There are different ways we could do it algebraically as well. And I can go into those, but right now I'm just going to have you guys do it by graphing. Further down the line, we'll start solving things through methods called elimination and substitution. But for now, graphing is where I want us to get started, to at least see visually where they cross and how that means that's the solution. Right? Does that make sense? The point 0,3 is true for both lines. You know, if I were to pick a point out here, it'd be true for the red line but not the purple line. If I were to pick a point here, it'd be true for the purple line but not the red line. And if there was another point here, well, it's not true for either line. All right. With that said, I also want to do a quick preview of tonight's homework. So I'll go ahead and move this to the side. Go ahead and open up your homework packets. And I just want to go over some of the questions with you guys before I let you guys be free to work on it. So we'll start with 1.7. I want to look at, in this case, we'll start with problem 2. Problem 2 I'll do for you here. It says 3x plus 2y all over 5 equals 7. And we're asked to solve for x. Okay? We're asked to solve this for x. And so the first thing we want to do is, we want to get x by itself eventually, but we want to start to simplify our equation. So looking at our left side here, I have this divided by 5, and that divided by 5 is pretty difficult to deal with. So the first thing I want to do is I want to get rid of that divided by 5. Now, if I'm dividing by 5, I have to multiply. Absolutely, good job. So I have to multiply by 5, because that's the inverse function. That gets rid of that. So I end up on my left side just 3x plus 2y. And then 7 times 5 is 35. Now I'm still trying to solve for x, and I have two terms. I have an x term and a y term. So I'm going to get rid of my y term. I'm going to subtract 2y. So I end up with 3x equals negative 2y plus 35. And I'm almost done. I almost have it solved for x. The last thing I need to do is isolate my variable by dividing by 3. So I end up finally with x equals, see how I have x equals? I know whatever I write on the right-hand side is going to be my answer because I have solved for x. Negative 2y plus 35 all over 3. All right. So you want to be careful when you see things like this, where you have that divided by, and it's divided by the entire side. You see that right here, the entire side was divided by 5, so we're going to start by multiplying by 5. Now, this could be tricky. I'm going to go into an alternate universe here. It's an alternate universe where the problem was slightly different. Let's say instead, and this isn't one of your homework problems, I'm just coming up with this one, but let's say instead I had 3x divided by 5 plus 2y equals 7. Slightly different problem. In this case, the divided by 5 isn't on the entire side, it's just on the x term. So now what's my first step going to be? Well, multiplying by 5 doesn't quite make as much sense on the entire side. What makes more sense is to get rid of this y term first. So I'll get rid of that y term first. 3x over 5 equals negative 2y plus 7. And now that my entire side is divided by 5, now I will multiply by 5. So I have 3x equals, that becomes negative 10y plus 35. And then finally, isolate my variable by dividing by 3. X equals negative 10y plus 35 all over 3. Okay? So be careful when you're looking at that, because this is a place where people can make some errors. If you multiply by 5 but don't see that this 2y is here, or don't see that this 2y isn't being divided by 5, that's a possibility for error. So what I like to do is I like to eliminate terms until I have it so that we are just dividing the entire side by a number before I start multiplying. Any questions on that? Yeah?
How does it become a 3 out of 7? 3x.
Here?
Yeah.
Because 5 divided by 5, that becomes 1. So that just becomes 3x. Because that's all I have left over. And you guys see how all I did was distribute this 5 here and here. Negative 10y plus 35. No. I essentially did do 4. This is very similar to 4. All right, next, what I want to do is I want to look at the next page and this section here where it's asking about inequalities. I'll zoom in here. Okay. All that this one is asking you to do is to rewrite the inequality each time. So you see, we have an original inequality. What's the original inequality? Well, it says it multiple times. 4 is less than 6, 4 is less than 6. And then this asks us to add 4 to both sides. So if I add 4 to 4, what do I get? 8. If I add 4 to 6, what do I get? 10. Is 8 less than 10? You betcha. So this is true. Okay. Now we're going to go back to our original inequality. We're going to subtract 4 from both sides. So what's 4 minus 4? 0. 6 minus 4? 2. Is 0 less than 2? True. So it's just going to ask you to do that each time to the original inequality. Felt like the way that it asked that was a little bit unclear, so I just wanted to show you guys how that is done. Easy enough? Questions? Yeah.
So the third one says subtract 10 from both sides.
Mm-hmm.
So would the lesser negative be the greater number? Or would it?
Whichever number is higher on the number line. So like, you know, negative 10 is still less than negative 9. You know, you would rather owe me $9 than owe me $10. So even though the number 10 is a larger number than 9, negative 10 is still less than negative 9.
Okay.
Yeah, right?
So when would you flip the sign?
Say it again.
When would you flip the sign?
It'll become, that's part of this lesson, is it'll become apparent when you flip the sign. Okay? You would flip the sign anytime it becomes false. All right, team.